Hey everyone, welcome Genesis International College students to this explainer on Topic 2, Setting Out Stair Components. I am absolutely thrilled to walk you through this material today because honestly, we're talking about the ultimate bridge between theoretical blueprints and physical, muddy site work. As you already know from your CPCCCA3016 studies, constructing timber external stairs isn't just about grabbing a saw and cutting wood. No way. It's about precision, it's about planning, and it's about translating a flat, two-dimensional drawing into a safe, three-dimensional reality that people are going to rely on every single day.
Okay, let's dive into this. Here's a quick look at our agenda. We're going to hit the construction sequence, decode some site-level terminology, and check out our tools for verifying heights. From there, we'll walk through physical site verification, marking layouts, and finally, how to manage real-world site variances.
All right, Section 1, Standard Stair Construction Sequence, moving from the site to safety.
Listen, following a strict chronological sequence is absolutely crucial on a build. If you do things out of order, you're literally just costing yourself time and materials. For most external builds, it breaks down into 3 core steps. First off, you've got to confirm the actual height from the ground to the landing right there on site. Do not just trust the paper. Second, you prepare the stair foundations like your concrete pads so you have a rock-solid base. And third, you set out the pattern on your timber and cut your stringers and treads. So remember, a successful build always starts with physical site measurements.
Moving right along to Section 2, Understanding Site-Level Terminology. Let's talk about the blueprint language.
Now, what's really interesting about this is how defining these terms side by side totally takes the mystery out of architectural abbreviations. Before you pick up a tool, you have to decode this stuff. FFL, or finished floor level, is the height of your final floor surface, like the actual decking or tiles, and that sets your top step height. RL stands for reduced or relative level. That's a height measured against a fixed point on site, which lets you compare your stair height to the rest of the build. And GL, that's just ground level, the natural ground height before you even start digging, giving you your base.
And mapping these out visually creates this huge aha moment. It completely bridges the gap between those clunky acronyms and a physical house layout. You can see exactly where the FFL sits right at the very top of the deck at plus 3.350, right there on the finished surface. The RL is marked way down at 0 as the site datum. That's our fixed point of comparison. And the GL just follows the sloped ground surface below. Seeing them mapped out like this, it just makes the math a whole lot easier to wrap your head around.
Section 3, Tools for Verifying Heights. Let's translate those plans to reality.
You know, site conditions are constantly changing. Dirt gets moved, paths get poured. Relying on drawings alone just isn't enough, which is exactly where your verification toolkit comes into play. First up is the laser level. During your initial site survey, this tool casts a perfectly horizontal line straight across your site. It establishes a highly precise, fixed reference point over long distances where a standard level just wouldn't cut it.
Next up, the trusty spirit level. In carpentry, when we say level, we mean perfectly horizontal. You're going to use this constantly on your treads and landings to guarantee a safe walking surface. Think about it. If your treads aren't checked with a spirit level, you risk creating major trip hazards. And absolutely nobody wants to be the reason the client takes a tumble, right?
And of course, the absolute staple of any carpenter's belt, the tape measure. This is exactly what you'll use for all those physical distance calculations. You're going to use it to record vertical distances and to measure precise setbacks from that datum point you just established with your laser level.
Let's move to Section 4 and see how this builds into the physical site verification sequence.
As you develop into master builders, this sequence literally needs to become second nature to you. Step 1, establish a reference mark. Step 2, get that laser level set up. Step 3, identify the bottom finished level where your stairs are going to terminate. Step 4, take your ground reading. You do that by recording the vertical distance from your laser line straight down to the ground surface at the stair base. Step 5 is where the math comes in. Calculate your total rise by subtracting your known reference height from that ground reading. That gives you the true vertical distance for your flight of stairs. And finally, Step 6, take multiple readings to verify if the ground is actually level, making sure you've got a safe, predictable surface to build on.
Section 5, Marking Layouts and Alignment for Structural Newel Posts.
So, newel posts. These are the main vertical beams that hold up your handrails and give the entire stair structure its strength. Layout always starts by transferring measurements straight from your plans to the site, constantly referencing that datum point. You have to maintain a perfectly consistent line, a straight longitudinal path between 2 points. Why? Because keeping this alignment dead on prevents crooked handrails and ensures your stairs meet the deck landing perfectly.
So, the crucial point here is understanding the distinct roles of the three main types of posts. First, you have the landing newel post, which sits right up at the top where the stairs join the deck. Second, the intermediate post. This guy sits right in the middle of a long run of stairs to add some extra, vital support. And third, the bottom newel post, which sits firmly on the ground or on a concrete pad right at the start of the stairs.
And finally, Section 6, Managing Real-World Site Variance. Welcome to the Rule of Variance.
Here's the truth. Beautiful, pristine paper plans rarely survive contact with the real dirt. There are a bunch of common disruptions that are going to cause your surface levels to vary. You'll run into the natural slope of the land, unfinished landscaping, or dealing with existing finishes. You have to account for house settlement over time, and of course, totally unpredictable soil conditions. This is just the messy reality of a job site. Troubleshooting these variances before you finalize your rise calculations is a vital survival skill in this trade.
Which brings us to our final thought for today. When your perfect paper plans clash with uneven, unpredictable dirt, will your site setup hold the line? I really want to challenge you to take these layout skills, anticipate those real-world site variances, and apply them with absolute confidence to your CPCCCA3016 practical assessments. If you master the laser level, decode the blueprints, and follow the sequence, you are going to build stairs that stand the test of time. Thanks so much for joining me on this explainer, Genesis College students. Keep learning, keep building, and I'll catch you on the next one.